The power transformers are electrical devices used to transport electrical power without changing the frequency from one circuit to another. They function according to the electromagnetic induction theory. They are employed in the electrical power transmission process between primary distribution circuits and generators. In distribution networks, power transformers are used to step up or step down the voltage. These instruments are regarded as static devices because they don't have any rotating or moving components. These devices are powered by an electrical system that uses alternating current, AC. A power transformer is simply a classification of transformers with a rating above 200 MVA and a voltage range ranging from 33 kV to 400 kV. Power transformers are available in the market with voltage ratings of 400 kV, 200 kV, 110 kV, 66 kV, and 33 kV. Distribution, 230 volts 11 kV, and instrument transformers are among the additional types of transformers. When transmitting large amounts of electrical power across long distances, power transformers are crucial for preventing significant energy losses caused by Joule's effect. They do this by turning the power into high voltage current and then stepping it down to a safer low voltage current. They can frequently be found in industrial facilities, power plants, and electric utility businesses. The electromagnetic induction law of Faraday is the basis for how power transformers work. All transformers, inductors, motors, generators, and solenoids operate according to this law. According to Faraday's law, a closed loop will create an electromotive force, EMF, across it when it is brought close to a fluctuating magnetic field. An alternating or fluctuating magnetic flux envelops the coil, primary winding, when alternating current is permitted to pass through it. A ferromagnetic core is necessary for the primary winding's magnetic flux to successfully transfer to a secondary winding. Due to electromagnetic induction, the magnetic flux will then cause an EMF in the secondary winding. The secondary winding's current flow will be prompted by the induced EMF. Power transformer components. The core and the primary and secondary windings are the fundamental components of a transformer. The core acts as both a structural support for the windings and a low-reluctance channel for the magnetic flux. Thin steel sheets are laminated and stacked to create it. A covering separates the sheets from one another. The iron or steel sheets are less than 1 mm thick, and their carbon content is kept below 0.1% to minimize hysteresis losses and eddy current losses. By incorporating silicon into the steel alloy, eddy current is further diminished. The limbs are the vertical portions of the core in which the windings are transported, and the couplings are the horizontal portions of the core that connect the limbs. The windings of a transformer. A specified number of turns of copper or aluminum conductor coil make up the windings. Due to its high electrical conductivity and ductility, copper is the ideal material since it requires less winding and is simpler to wrap around the core. The primary and secondary windings make up a transformer's minimum number of windings. The winding to which the input voltage is applied is known as the primary winding, and the winding to which the output voltage is supplied is known as the secondary winding. A transformer's phases main and secondary windings can function as either the high voltage, HV, winding or the low voltage, LV, winding. HV winding. The HV winding has a greater number of turns and consists of a thinner conductor than the LV winding. LV winding. The LV winding has a fewer number of turns. It consists of a thicker conductor than the HV winding since a higher current is carried in the LV winding. Transformer insulating material. The primary and secondary windings, as well as each winding turn, are all isolated from the core by means of insulating materials. These components shield the transformer from harm. High dielectric strength, superior mechanical qualities, and the ability to endure high temperatures are required for transformer insulators. Although paper and pressboard can be used as insulators, i.e., dry-type transformers, their service lives are constrained and they need to be replaced frequently since these materials might deteriorate. Transformative oils are therefore more prevalent than solid insulating materials. They function as a coolant for the coil and winding assembly, offer improved insulation between conducting elements, and contain fault detection features. Transformer oils are hydrocarbon mineral oils made up of aromatics, paraffin, naphthene, and olefins. Tap changer. By altering the number of turns in one winding, tap changers are devices that control the transformer's output voltage as it responds to the varying input voltage and load. As a result, the turn ratio is altered by this alteration. The output voltage rises during off-loading conditions whereas it falls under loaded conditions. In order to achieve precise voltage regulation and reduce core losses of the transformer, tap changes are frequently attached in the HV winding. Additionally, the HV winding's reduced current reduces the possibility of sparking and igniting the transformer oil. Tap changes come in two varieties. On-load tap changes are made to tap the voltage without interfering with the passage of current to the load. Unlike unload tap changes, which must first operate without the transformer's load. To learn even more about the transformer, stay tuned for part 2. Like, share and subscribe. Thank you for watching.